Hey Chem Kids, Campbell here. In our video today, we're going to talk about gases and amount. So we're going to talk about Avogadro's principle, which we mentioned in our last video. We're going to talk a little bit more about it today. And we're also going to talk about the ultimate of gas laws, the ideal gas law. So what Avogadro's found was that regardless of what type of gas it was, if I have an equal volume of gas at the same temperature and pressure, I'm going to have the same number of molecules or moles. Isn't that crazy? It doesn't matter if it's a diatomic gas like oxygen or a polyatomic gas like carbon dioxide or a monoatomic gas like helium. As long as they're under the same temperature and pressure, they have the same volume. Totally cool. Now, what he found, right, which makes sense, is that volume and amount are directly related. All right, if I add more molecules or moles of gas to this balloon, its volume's going to go up. And because they're directly related, right, if I double the number of molecules, I'm going to double the volume. Or maybe I take molecules out and the volume goes down. So his equation, a direct relationship equation, is one divided by the other. So the amount in moles divided by the volume in liters at one condition is equal to the amount in moles divided by the volume in some other condition. That's Avogadro's principle. So let's try some. How many moles of helium are in a 5-liter balloon at STP? Wait. I need conditions 1, N1 over V1 to equal conditions 2, N2 over V2, but I only have one number here. What am I going to do? Well, you know what we have to do? We have to remember back to last semester. Oh gosh, not last semester. Remember in the mole unit and then again in the stoichiometry unit? Remember we had a relationship between amount in moles and a volume? Do you remember what that relationship was? And remember I said it was at STP, but you didn't really have to worry about STP yet. We have to worry about it now. But under standard temperature and pressure, if you remember, 1 mole is 22.4 liters. So there's my other conditions. So that stinking STP, that was telling you what the conditions were. All right, so we're going to call this my original conditions. There's my V1 and there's my N1. And we're going to say that the moles that I'm solving for is my N2 and this is my V2. So plug in your numbers. They're your variables. Plug in your numbers and see if you can do some good algebra. Well, if you got 0.22 moles, you are correct. All right, that should make sense because we decrease the volume, which means we need to decrease the number of moles because they're directly related. Let's try another problem. I have 35 grams of neon gas in a 50-liter container, and I want to know what volume 5 grams will occupy under the same temperature and pressure. Well, it doesn't say anything about STP, so I can't use the whole 1 mole is 22.4 liter thing. But I'm in grams. And remember that amount needs to be in moles? Well, what do I do? How do I go from grams to moles? Do you remember? I know. I'm asking you to remember stuff from last semester. Going from grams to moles, we divide by molar mass, or in the case of neon, atomic mass. So you got to find neon on your periodic table. There it is. Or up there. 20.1798 grams per mole. So we're going to take our 35 grams, our initial condition, divided by 20.183, and 5 grams divided by 20.183, because we need to get those into moles. Now that we have them in moles, we can set up our equation. So amount in moles divided by volume. Now, the 35 grams goes with the 50 liters, so those are going to go in one side. And then my new amount is going to go here. So that's what my equation should look like. Now, let's see if you can do some good math, because I got something on the bottom. And this is where you guys tend to do bad algebra. in order to do the correct algebra, well, let's see if you did it. Plug it in, do some math. Did you get 7.16 liters? If you didn't, you did not do good math. So in order to solve this, right, you have to cross multiply. So V2 comes up here and 50 goes here. So you should take 0.248 and multiply by 50. And then you're going to bring the 0.17 or 1.73 down here. So you're going to divide that quantity by 1.73, and that will give you V2. So if you did that, you got 7.16 liters. All right. That's Avogadro's principle. So sometimes you're going to have moles, and you're good to go. But sometimes you're going to get grams. So you got to remember, you got to divide by the molar mass or atomic mass. Periodic table. All right, our last gas law that I want to talk about is called the ideal gas law. The ideal gas law combines everybody's laws together. All right, I have pressure and volume, Boyle, pressure and temperature, Gay-Lussac, volume and temperature, Charles, and now I have amount, Avogadro. But what's this R? Well, that's actually a constant. So very important that we work in the correct units, because the value of the constant R is 0.0821, and the units are liters, atmospheres, moles, Kelvin. So that means every time you work with the ideal gas law, your pressure has to be in atmospheres. Your temperature, of course, has to be in Kelvin, regardless. Your volume has to be in liters, and N is number of moles, so you have to work in moles. So if you are not in these units, you need to convert to these units before you can plug into the ideal gas law. All right, so let's see what that means. I want to know how many grams of nitrogen is required to fill a small room with a volume of 27,000 liters to 1.09 atmosphere at 25 degrees Celsius. All right, so what do we got? We want to know grams, so that's an amount. We have a volume in liters. Good. We have a pressure in atmosphere. We have a temperature, of course, in Celsius, because who measures in Kelvin? But we need to make it to Kelvin. So we're going to list all the things that we have, our pressure, our volume, our amount is what we don't know, but we're going to solve for moles first, right, because N will be in moles, but then we're going to have to calculate grams. There's our constant, and of course temperature, add to 73, so that's 298 Kelvin. Now it's just a matter of plugging and chugging. Plug in your pressure, volume, constant, and temperature. Right, there's our equation. Our unknown is the little amount there, the N. And then we're going to divide by the constant temperature, right? That'll cancel it out from this side, and we'll solve for amount in moles. So do some math. Let's see if you get the right number of moles. If you did this correctly, you should have 1,203 moles of nitrogen. But we're not done, because remember I wanted grams. So how do we go from moles to grams? Periodic table, but what do? Do we multiply or divide? So remember, when we have moles, we multiply. So we're going to convert moles to grams by multiplying by the molar mass of N2. So find nitrogen on your periodic table. Multiply that number 2. Nitrogen's 14. Multiply it by 2. That's 28. So we're going to take 1,203 and we're going to multiply by 28. So that gives us 33,681 grams. Wow, that's a lot of nitrogen. That's a really big room. All right. Go to your turn-in sheet. Fill that out. Bring it to class. We're going to talk about the ideal gas law in class. See you tomorrow.